Hey guys, this is Circular Functions. Our objective is to solve equations using the unit circle. So on these problems, you're not going to be allowed to use your calculator, and they use a lot of special triangles in these types of problems. So let's just refresh our memory of what they are. So you have a 30, 60, 90 degree triangle, and the ratio of those sides is opposite of 1, you should have, or opposite of 30, you should have 1. Opposite of 60, you should have square root of 3. And opposite of your 90 degree angle, you should have 2. But because this is on the unit circle, we have to have a hypotenuse of 1. So I make it 1 by dividing all sides by 2. So across from the 60, you'll always see square root of 3 over 2. Across from the 30, you'll always see 1/2. And then you have the 45, 45, 90 degree triangle. The ratio is 1, 1 square root of 2. But again, you want your hypotenuse to be 1, so you divide all sides by square root of 2. The only problem is that we don't like radicals in the bottom of our in our denominator's place. So if we multiply the denominator and the numerator by square root of 2, we get square root of 2 over 2 as our sides. Okay, so keep these in mind when we're going through these next problems because you'll need to know them in order to figure out or to solve these problems. Also, remember that when you're talking about solving for trig functions, there's not just one answer, right? There's multiple answers. And a lot of that depends on the limits of your variable, right? So if it says that x is in between negative 360 and 360, well, that's 2 times around the circle. And 1 time around the circle, you have 2 options for every trig function, right? So for sine, you have sine of x is positive in the first and second quadrant. For cosine, it is positive in the first and fourth quadrant. And tangent is positive in the first and third quadrant. But if you multiply that times 2, then you have 4, right? So you have to pay attention to the limits of your x value or your variable. Okay, so one thing I wanted to say is that if you're going to have, if like it says x is in between negative 360 and 360, this is what that looks like. So you'll have theta, right? You're always going to start out with theta because it's all the trig functions are positive in the first quadrant. And then you have the next one, which is 180 minus theta. And then you have it from the negative direction. And that is negative 180 minus theta. And then to go all the way around back to the first quadrant, it would be negative 360 minus theta. And you can kind of follow that pattern with the next 2 as well, like trying to figure out how to find that angle. I'm not going to go through it, but I think that you guys can try to figure out those. Okay, so let's solve an equation. Our equation is cosine of x equals negative square root of 2 over 2. And x needs to be between 2 pi and negative 2 pi. Okay, so notice that we're dealing with radians. You can solve it using degrees, and then you have to convert them to radians, or you can just go with radians from the beginning. We're going to go with radians from the beginning. So I need to find an angle that's cosine is square root of 2 over 2. So if I go back to these to these special triangles, the one that has square root of 2 over 2 is the 45 degree triangle. So I know that x is going to be 45 degrees, and if you convert that into radians, you get pi over 4. Okay, so if I'm looking at the unit circle, I know that cosine is positive here and here. But I don't want where it's positive, I want where it's negative. It is negative in the second quadrant and in the third quadrant. So I'm going to draw lines going into those quadrants. This helps me recognize what I need to do to find the angles that fall into those quadrants. So we said that this is 45, or pi over 4, right? Now I just want to find out what this angle is. So you start from the initial side and you go to the terminal side. So what is that angle? So this would be it would be pi minus pi over 4. And then if I came all the way around to the second angle, that would be pi plus pi over 4. And I also want to look at the negative part, right? Because x goes between 2 pi and negative 2 pi. So I've done the 2 pi part. Now I'm going to go and do the negative pi, or negative 2 pi. So you have to go clockwise. And then this is just negative pi plus pi over 4. And then to come around here, this would be negative pi minus pi over 4. And then you can solve each of these and you get 3 pi over 4 and 5 pi over 4, and then negative pi plus pi over 4 is negative 3 pi over 4, and then the last one would be negative 5 pi over 4. So these are the answers to the problem cosine of x equals negative square root of 2 over 2. So remember, you have to determine what angle are you talking about, and that's given to you by looking at the answer to the equation, right? So if I'm looking at square root of 2 over 2, then I know that I'm dealing with a 45-degree angle. And then you have to see if it's positive or negative, because that tells you which quadrants you're in. And then you have to determine how many multiples of these angles are you going to have. So this is what helps with that. Okay, let's do another one. So we have solved the equation of tangent of x equals square root of 3. And it says that x is in between 0 and 720. So that's going to be two rounds of 360. So whenever you find your answer, let's just go with it. So tangent of x equals square root of 3. I know that whenever I'm dealing with square root of 3, I'm probably dealing with a 30, 60, 90 degree triangle. So if you want, you can always draw that, and then square root of 3 is the opposite. So, and then the adjacent would be 1. So when the opposite is square root of 3, then that means that the angle needs to be 60. And tangent is positive in the first quadrant and in the third quadrant. So this is going to be 60. Let me do that better. 60 and 60. So now we just have to find all the angles that match that. So we have theta. That's this one right here. And then come around to here, that's going to be theta plus 180. So this is going to be 60, and then this is going to be 240. Now, I want to go around again, so I want to make one full circle, so that's 360 plus theta. So theta plus 360, which is going to give us 420. And then you want to take the second one, which was theta plus 180, and you're going to add 360 to that one as well, and you get 600. So these are the answers to the problem tangent of x equals square root of 3 when x is in between 0 and 720. Okay, taking that a step further, if we said to solve the equation tangent of 2x equals square root of 3, well, we know that tangent of x equals square root of 3. We already know the answers to that. When it's in between 0 and 720, we said it was 60, 240, 420, and 600, right? But instead of x is in that place, we have 2x. So I could have called this like a and solved for a and then said, well, a actually equals 2x, solve for x. And so then you would just take each of these answers and divide by 2. And so now x equals 30, 120, 210, and 300. So if there's anything different that you're taking the tangent of, then you can just substitute some other variable there, solve for that variable, and then say, okay, well, actually, that variable is you're taking the function of. So like if you were taking sine of 3x divided by 4, and that equaled 1/2, you could say that you were going to take the sine of a equals 1/2, solve for a, and then whatever answers you get, you say, okay, well, a doesn't actually equal a equals 3x over 4, and then you have all of these answers, alpha, beta, whatever. And then you would solve for x for each of those answers. Okay, some things to remember. Quadratics. I know you guys love quadratics, I hope, because I do. So whenever you're solving quadratics, you get two binomials, right? And this term is the first two terms, or the first term in each binomial. So you have 2x, and then you have the factors of 3 that go in this position, and then you have to add to be 5. So there's only two factors of 3. One is 1 and the other is 3. And they don't necessarily have to be in this order. They could have been the other way, but we want 2 to multiply by 3 in order to get 6, and we want 1 to multiply by x to get 1. And then you have to determine which one is positive and which one is negative. You want the 6 to be positive and you want the 1 to be negative because you're wanting to subtract 6x and 1x, or 1x from 6x. So this would be the factorized form of 2x squared plus 5x minus 3. If you need to revise that, then you can always come see me, or, whatever. Also note that sine squared of theta is the same thing as sine of theta and then all of that squared. Those are the same things. Okay, the reason why we go over this is because you can use this knowledge to solve this type of problem, right? So before I told you that, like if you're taking sine of 3x divided by 4 equals 1/2, and you wanted to solve for what 3x over 4 is actually equal to first, you could substitute. You could do that here as well. You could say 2a plus 5, or 2a squared plus 5a minus 3, and you could factor it that way and then go back and substitute in sine of x for a. So if we wanted to do that, of course we already we just did this problem on the last slide, so you'd get 2a minus 1 a plus 3, and then you would go back and substitute in sine. So 2 sine of x minus 1 and 2, or not 2, but sine of x plus 3. So what you would do is take each of these and set them equal to 0. And when I say each of these, I'm talking about these binomials, right? Because that's how you would solve this right here. Okay, so let's do that. So we have 2 sine of x minus 1 equals 0. So I'm going to add 1. And I don't know if you guys like show all of this work, but I like to, just in case I mess up and I want to see what I did wrong. So sine of x equals 1/2. You can always make a triangle to show what that looks like. So the opposite is 1, the hypotenuse is 2. So this is 1, 2 square root of 3 triangle. And so always across from 1 in this type of triangle, I'll have 30 degrees. But we want it in radians because that's what x needs to be in between, is 0 and 2 pi. If you convert 30 degrees into radians, you get pi over 6. And because sine is positive in the first quadrant and in the second quadrant, then this is going to be pi over 6, and then this is going to be 5 pi over 6. So x equals pi over 6 and 5 pi over 6 for that binomial. And then you have the second binomial, which is sine of x plus 3 equals 0. So we're going to subtract 3. And we get sine of x equals negative 3. Well, we can stop here. The reason why is because sine of x can never be anything less than negative 1. So this doesn't give us any valid answers, doesn't give us a real number. So our answers are just x equals pi over 6 and 5 pi over 6. Okay, so we're going to do more practice on this when I see you guys on Monday or Tuesday, one or the other. Anyways, have a good night and have a good weekend.